These ones are based off of what we did yesterday, except yesterday they would just say determine the angle in standard position, right? And I gave you a trig ratio, and I gave you where it exists, and then you get me the angle in standard position. In 20-1, I can only ask for angles in standard position because I can only go between 0 and 360 anyways. But next year it won't say angles in standard position, it'll just say solve. And then what we'll do next year is we might go 270 to 360, or we might go negative 270 to, or negative 360 to negative 270, because we can do negative angles next year. We might do radian measure next year. So we're just practicing the solve part between 0 and 360 this year, because that's all we can do. Okay? So our first step is always to draw. Step 1 is draw. So I always look to the second piece of information to help me out. And sometimes you have to look at the first. So let's look. 270 to 360 falls here. We agree? Is cos negative here or cos positive here? It's positive. Because what is cos on the unit circle? X or Y? X. So cos is actually positive here and here, because x's are both positive here and here. We agree? Right? So that does seem realistic. It could have been in both quadrants. It could be in quadrant 1 and quadrant 4, because x is positive in both, and I said cos is positive. But then I narrowed you down to quadrant 4. Okay, so I drew it. Second step, reference angle. And how do I do the reference angle? I do inverse trig of this. So if I have cos x equals negative a third, I'd still do positive a third. We always do the positive, right? That's how we get our reference angles. So we're going to do x equals cos neg 1 of a third. And what do we get in degrees? To the nearest degree? 71. We agree, disagree? Yeah. Hey, so I drew a triangle there. Did I need to draw a triangle when I'm solving? When I'm trying to find the angle, do I need a triangle? No, I need a triangle when I'm asking for a trig ratio, correct? So if I give you a trig ratio and then I ask for cos, sine, tan, whatever, when I ask for another trig ratio, I draw a triangle. If I'm just asking you to solve for the angle or the standard position angle, I just need an arm. Kylie?
If we don't draw it, will we have marks taken off?
Well, if you don't draw it, when we get to the next ones that are harder, you might make mistakes.
Okay.
Yeah, so you wouldn't actually lose marks. You're just you might lose, unless it says sketch. But because it doesn't say sketch and you just gave an answer, you wouldn't lose marks, no. So we start with our initial, we go to our terminal, and we know our reference angle, so the bow tie angle is 71. Now when I'm in quadrant 4, remember in quadrant 4, I'm going to label 0, 90, 180, 270, 360. When I'm in quadrant 4 to get the actual angle, I always go 360. And look, it's not theta this time, it's x, correct? So I'm going to go x equals 360 degrees minus 71. And x equals 289. Yeah? You need the x equals. Because the word here that I gave you is solve. And whenever I give solve, your answer doesn't matter what course you're in, doesn't matter what math course you're in. If the question is, the word says solve in it, my answer needs to be variable equals some answer box, right? That's what solve means. Solve means give me the variable equal to a number and box it. That's what solve means. So because it says solve, I know in the end I need something that looks like this as my answer. Because I'm solving for what that x is. And now you can check it. Go cos 289 into your calculator. You should be able to check whenever you solve. Solving is the best because when you get an answer, you can always check and see if left side equals right side. So if you go cos 289, whenever it says solve, we can check. Cos 289 degrees. Hopefully it equals a third. So 0.333333. Does it? Did you round it? You rounded the 71, right? So is it close to it? Yeah. So it's not going to be perfectly 1/3 and 1/3 because we rounded. This wasn't an exact value, right? So keep that in mind. When you're not using an exact value, you're not going to get it exactly 1/3 and 1/3, right? Because we rounded. All right, 2. Tan x equals this. So the first thing I'm going to do is sketch. So I need it between 90 and 180. 0, 90, 180, 270, 360. So I need it between 90 and 180. Is this the most accurate sketch? No, because I don't even know what the reference angle is. I just threw an answer in there, right? 2, reference angle. So I'm going to go tan x equals 3/2, not negative, right? We always use the positive to get the reference angle. And then we're going to go x equals tan neg 1 of 3/2. And what do we get? 56. If you get an answer outside of 0 to 90, you did the negative. Yeah.
Wouldn't it be in like quadrant 2?
What? 0 to 90 is not 90 to 180? Yeah. Oh, how do I undo that without wrecking it? There we go. Yeah, it's totally not right. Okay, so that's our reference angle. So this here is 56, right? In quadrant 2, how we always get our actual answer is, what's our variable this time? X. In this whole worksheet, it's going to be X. But on tests in 30-1, it could be X, it could be theta, it could be M. They could change that to whatever they want to change it to, right? So when we go to answer it, we always look for what the variable is. Okay, the variable is X, so I'm going to have X equals, and then I figure it out. If I had an M here, this would be M equals. If I had a theta here, it would be theta equals, right? You're just trying to find out what the variable equals. Now in quadrant 2, how we always get the answer, we do 180 and we subtract off our reference angle. So we do 180 minus 56, and we should get 124 degrees. How'd you do on those two? Good? Yes? Thumbs up? Good? Okay. So for 3, it's a bit different because I didn't give you the actual exact quadrant. I didn't say quadrant 2 and I didn't say 90 to 180, right? I gave you a little bit something different. So what happens? Same steps. Number 1, you have to draw it. I told you guys to get the reference angle. That's fine, because that's what I knew you could get instantly. But our first step is going to be to draw it. Now, how the heck do we draw it? Okay, we know sine is negative. Where is sine negative? What is sine? What variable? Y. And where is y negative? In the bottom, right? So we know it's going to be either here or where I'm going to draw my terminal arms. Does that make sense to people? Okay. But we want where, and then the second piece of information cuts off one of these arms. So I want where tan is positive. Tan is positive when I divide 2 negatives by each other or 2 positives by each other, right? Where are the coordinates both positive or both negative? In the bottom left and the top right. Now there's this rule called CAST rule. I'm going to show it to you. But you can just use your brains, and you know that this is positive here and here, so it would not be this one, it would be this one, because where tan's negative. But this is what you can do. There's a rule called CAST rule. I want a different color. So what it does is the C starts down here, C, A, S, T. So CAST can help you out as well if you don't want to try and think about where cos is negative, where tan is negative, etc. Okay? C stands for, what do you think? Cos. S stands for sine, and T stands for tan, and A stands for actually all of them. So where those letters are is where they're positive, right? So we just said, where is sine? Well, where's sine negative? So, well, sine's positive in S and all, correct? So where's sine negative? Here and here. That's why I drew those arms, correct? And then I want where tan is positive. Well, where's tan positive? Tan's positive in the all and the tan. So that's why it doubles up there. So you can use CAST rule as well. So this is another thing we can say, hey, I need where sine is negative and tan is positive. So I need where I don't have an S and where I do have a T. Where do I not have an S and I do have a T? Quadrant 3. Does that make sense? So that's how we figure out where to draw it. We need it where sine is negative. I need it where sine is negative and tan is greater than 0, so tan is positive. Well, where is sine negative? Here and here. Where's tan positive? here and here. Where do I double up? Only here. Make sense? So this one here doesn't exist. Okay? Now we found how to draw it. Now we do the same rules we did before. Reference angle, get answer, right? That's it. The only extra I did here is I made you find out where to put it. So step 2 is reference angle. So we're going to go sine x equals a half, because we don't do the negative when we do reference angles. X equals sine neg 1 of a half. What did you get? 30 degrees, right? So this here is 30. And in quadrant 3, what do? I'm going to do this for your welfare. Quadrant 3, I always go 180 plus the 30, right? What's my variable? X. X equals 180 plus 30, which equals 210. So we're going to try number 4 together. Oh, I'm missing a variable. This should say sine x. That's a typo. That should say sine x. Put an x in there. So my first step is going to be to draw it. That doesn't change. So it might help you to actually write cast. When I don't give you an actual degree here, you're going to write your cast. So it starts in the bottom left, C-A-S-T. Some people don't use cast. They start in the quadrant 1 to 4, and they go all students take calculus, which isn't true, but you can use it that way too. So all students take calculus, and then it's quadrant 1, 2, 3, 4, and it follows the same thing. So let's narrow it down. We need where cos is. This is a positive fraction, right? So we need where cos is positive, and where sine is less than 0. So we need where sine is negative. Which quadrant? 1, 2, 3, 4 is cos positive, so the letter C exists, but sine does not. Yeah. The bottom right. So in 4, right? Now let's narrow it down. We can do these in different colors, so I can do just to prove it. Cos is positive here in the C and in the all. We agree? Then in a different color, let's use green, I can do where sine is negative. Sine's negative in T and C, right? Because tan's positive here, and so here and here. Where did my arrow double up? Quadrant 4. So that's why it's in there. So if you want to, you can draw these separately. Draw this in one color, draw this in another color, and where they double up is where you keep it. Does that make more sense too? Everyone get that? Okay. I have 3 head nods. I'm going to say that everyone gets it. So we're here, okay? Because these only had single colors, and we doubled up in quadrant 4. So step 2, reference angle. So we're going to do cos x equals 2/3. X equals cos neg 1 of 2/3. X equals what did you get for a reference angle? 48 degrees. Don't forget the degree symbol, because next year if you don't have the degree symbol, it's a radian measure. It's totally different. So don't forget your degree symbols. So, and it is a reference angle, so it's from the x-axis down, right? It's your bow tie angles are your reference angles. So this is 48. And we're in quadrant 4. 0, 90. In quadrant 4, we always find the angle by doing 360 minusing it. So what's our variable? It's x. X equals 360 degrees minus 48 degrees. And x equals 312. Yeah? Flip over. So what I want you to do is the next whole page, or no, not the next whole page, sorry, 5 and 6. 7 and 8 are a little different. So you can do 5 and 6. So you're trying 5 and 6 out. They're the same as what we just... So, first thing we have to do is get my marker. Okay, so we have to draw it. Number 1. So we need where tan, C-A-S-T. We need where tan is negative, and we need where cos is greater than 0, so positive. So where is it C but not T, basically? Because cos positive is C, but not T. Yeah, down here. You picked up David talk. So it goes here.
What?
Yeah, he's not with us.
I got that too.
You just did a let's go like you normally do. But you were somewhere else. All right. Number 2. Reference angle. So we have tan x equals 5 over 2. We always take the positive. X equals tan neg 1 of 5 over 2. And what do we get? 68. So this here is 68 degrees. And when we're in quadrant 4, we always go variable, which is x still, equals 360 minus our reference angle. And we should get 292 degrees. Just remember in quadrant 4, 360 minus the reference angle. Sticks. First thing we have to do is draw it. So we need where sine is positive, root 3 over 2, and cos is positive. So I'm going to do cast, C-A-S-T. I need where there's an S and a C, y'all, right? So if I need 2 letters to show up, the only place 2 letters show up is in quadrant 1. Do we agree? So when it's positive, you look for that letter. When it's negative, you don't want that letter. And in this case, they're both positive, so I want the S and the C. Well, the only place where S and C are both existing is all, which is here. Number 2, reference angle. So we're going to do sine x equals root 3 over 2. X equals sine neg 1 of root 3 divided by 2, which is 60. And our reference angle and quadrant 1 angles are the same, right? Quadrant 1's the easiest. So number 3, variable, which is x, equals 60. What's the difference in number 7 compared to what we just did? What's up with 7 compared to 6 and 5 and 4? Yeah.
They're not fractions.
Yeah. It's not sine equals something. It's not cos equals something. So we need to get it to be that, right? If we have sine equals something, we just do all the same steps we've done over and over and over, right? Correct? It's the exact same question if we have it in sine equals or cos equals or tan equals, correct? So our problem right now is that we don't have it in sine equals. We have it in 3 sine x equals. So we're a step away from doing 1, 2, and 3, right? What do I do to get it to be sine x equals? Yeah.
But you divide 3.
Yeah, that's it. Divide the 3 over. We're just doing algebra. And now we have sine x equals a third. And now we not just sine x equals a third, cos x equals, or cos x is less than 0. Are we not just back to numbers 5 and 6 again? Just that one little step? Yeah. So for 7 and 8, that's what you're going to do. You have to get that one step over, and then you do exactly what we just did. So this one we're going to have to divide negative 2 over. So try that out. Okay, so first thing we got to do is draw. So we need where sine is positive, 1/3, and where cos is negative. So I need C-A-S-T. I need to see the letter S. I need to not see the letter C. So where does that happen? Right there, right? I see the letter S. I don't see the letter C. Okay. I don't know why I drew a triangle. Ah. There. Okay. Step 1. My brain has stopped. I teach 3 different math classes, and sometimes my brain just halts, and it goes, what are you in? What are you doing? That's what it does. It just did that. It's like, has like a, like, just needs to have a little breather and be like, ah, yes, Craig, grade 11, that's where you are, Crystal. And then it's like, oh, yes, that's where you are. And then we carry on. My brain, and it's a scary place to be sometimes. Okay, so we do sine reference angle, sine x equals a third. So x equals sine neg 1 of a third. And what do you get? Anyone but Bowden, because he's done. He's put in a good shift. Anyone? Bueller? David!
What?
On your phone, that's why I picked you.
Number,
Come on, my friend. Yeah, number 7. He even took out his earbuds. That's how hardcore this is.
Is it 161?
I want the reference angle.
Oh, the reference angle? 19.
19. Everyone agree? Disagree? Agree? And then our reference angle's here. It's between the x-axis and the terminal arm. In quadrant 2, we find our x equals, and we do 180 minus 19, and we should get 161. Okay, number 8. So we have negative 2 cos x equals 1. So I have to divide by negative 2. Because before we can even do 3 steps, we need to have cos x equal to something. Or we can't do our 3 steps, right? That's the key thing to all of this. So we have cos x equals negative a half, and sine x is less than 0. So if I ever say solve, the very first step, before we can even do step 1, 2, and 3, is to get sine, cos, or tan by themselves, right? Or else we can't even, work. So number 1, draw. C-A-S-T. I want where cos is negative. I want where sine is negative. So I actually don't want to see the letter C or S. Which quadrant am I in? The bottom left in 3. I'm in where there is a T, because that's not the letter C and that's not the letter S. So I'm right there. Step 2, reference angle. X equals cos neg 1 of a half. So I'll take the positive, and that's 60. So here would be 60. And in quadrant 3, I always do 180 plus 60. Looks like an alpha. Which is 240. Flip over. What's the problem with 9 and 10? And 11? And 12? There's so many problems. So little time. What's the first problem? Any problem? For 9 and 10? Yeah.
There's an addition for 9.
Yeah. This isn't in tan equals at all, is it? So the first thing before I do step 1, step 2, step 3 is to get it into tan equals, right? So let's do that first. 2 tan x plus 2 equals 0. So what's the first thing I have to do? Minus the 2. So I get 2 tan x equals negative 2. Now I'm like I was in the previous steps. What do I have to do next to get tan by itself? Divide by 2. So tan x equals negative 1. And x has to be between 0 and 360. What? This is like a mixture. I didn't really tell you what quadrant. I just said it has to be between 0 and 360, correct?
Yeah.
I didn't narrow it down to one quadrant, did I? When it's between 0 and 360, you might get more than one answer. So I'm looking for when tan equals negative 1. So I want where tan is negative. And then normally I'm like, we're cos pop, or we're sine it, or we're tan. Oh boy. What's the only thing I gave you? That's the only thing I gave you. The only thing I gave you is tan has to be negative, didn't I? And then it has to fall there. I know, so clear, right? That's all I gave you was tan's negative. So basically I'm screaming at you, it can't have the letter T! That's what I'm doing, screaming at you. So that means I have two places it could be, don't I? S and C. Boom shakalaka. You were right. Boom boom. Boom boom. The problem is I didn't give you a second piece of information to knock one of those arms off, did I?
No, you didn't.
So what am I going to get now? Two answers. Yes, I'm going to get two answers. Yep.
I just have a question.
Mhm.
For like tan, you just do like negative 2 is y and then 2 is x. Because what tan is, it's like y over x.
This is true, but why? What would you do with that?
Because then you have like if y is negative or if x is positive.
Yeah, but the negative sign can flop. Yeah. So you could use your reasoning. Yep, totally. So I see what you're saying. I didn't see what you were saying first, but I get it. So y is negative tan is, or y is negative x is positive. That would be here, right? But the negative sign could move to the bottom. So then I also need where y is positive and x is negative, which is here. So you can use that reasoning as well. I see. I'm picking up what you're laying down. I was not. I was very lost before, but I am now in the same place as you. Okay, but yes, you can do that. Okay. So do you see when I narrow you down with one, but don't narrow you down with the other, you're going to get two answers possibly. We agree? So let's go. Step 1, draw a graph. Not happy because there's 2, but you're okay. You may not be happy, but you're right. Okay. 2, reference angles. So we are going to go tan x equals 1, because we always use the positive. And we do x equals tan neg 1 of 1. And what do you get for your reference angle? Rhymes with Smorty 5.
45.
45. I had nothing. Yeah. Could have said like 40 live or something. Maybe I was really off. Anyways, it's 45. Now we just have 45 in 2 spots. Because why not, right? Like, 1 answer is good, 2 better. That's what I always say. So here's 45. And here's 45 as well. So we're just literally getting 2 answers this time. We're getting 1 in quadrant 2. We're getting 1 in quadrant 4. When we're in quadrant 2, we do x equals. In quadrant 2, we do 180 minus 45. And we get 135. 1 answer. Then we do our other one. When we're in quadrant 4, we do 360 minus 45. And we get 315. So when I don't narrow you down on the second piece of information, you're going to get 2 answers. Most times. 10, 11, and 12. Try them out. And go. Bless you with an all. Yeah. Oh my gosh. It's up. No. No. All right. I heard correctly. So for this one, we're going to divide the 2 over, and we're going to get cos x equals a half. And then we have no narrowing down, but we have cos has to be positive. So I need to look for where the c's exist. Where do c's exist? Where c is, and where a is. Step 1. Step 2, reference angle. X equals cos neg 1 of a half, which is at 60. So I have 60 here and 60 here. So in quadrant 1, we're done. X equals 60. Reference angle and angle are the same. In quadrant 4, we take 360, subtract it. And we get 300. For 11, we have to subtract the root 3 over, so we get 2 sine x equals negative root 3. Divide by 2. sine x equals negative root 3 over 2, and no narrowing down. So I want where sine is negative. So basically, I want where there is not an s. Where is there not an s? Quadrant 3 and 4. Because I want where sine is negative. So I don't want s's. There's an s in s, and there's an s in all. Right? So these two. Step 2. Reference angle. So x equals, and then I do sine neg 1 of the positive, so root 3 over 2, which is also 60. So it's 60 here, and it's 60 here. So for the first one, when it's in quadrant 3, we do 180 plus 60. So it's 240. And then in quadrant 3, we do 360 minus 60. That's 300. I thought, Aiden, you were clapping. But I now see you were just tapping. Okay, the last one is a little bit of a challenger one. It's already in cos x. And then you're like, dude, is that positive or negative? It's neither. It's cos x equals 0. When it's 0 or 1, when it's 0 or 1 or negative 1, it's going to fall on arms. So when cos x equals 0, we want, this is a unique. When it's cos x equals 0 or 1 or negative 1 or sin x equals 0, 1 or negative 1, it's going to be on an arm. So I want where x equals 0. Where is x equal to 0? Right meow and right meow. Yeah. So x equals a 90 and a 270. That was a trickery. If it was cos x equals negative 1, if it was cos x equals negative 1, it would be here, right? That would be the only answer, because that's where x is negative 1. And if it was cos x equals 1, it would be here, because that's where x equals 1. And then sine is opposite, because it's less. Yeah? That's gut. Okay. Homework. Can I steal your textbook again? And my textbook. I cannot remember to bring mine back. It's on my desk in my basement. Thank you.
Yeah.
So we're still on page 96. You're doing numbers 7 to 9. We have 17 minutes. 17 minutes. Page 96, numbers